Okay, section 4.1, we are totally changing the direction of what we're studying. So we're looking at anti-differentiation now. In chapters 1 through 3, we covered differential calculus. Now we're going to be looking at integral calculus that allows us to determine accumulation of a quantity based on a given rate functions. So we're going to have different theorems and properties that we're going to have to look at. Theorem 1 tells us that the antiderivative of f of x is the set of functions f of x plus c such that the derivative of f of x plus c is equal to the function f of x. The constant c is called the constant of integration. If f is an antiderivative of f, then we write it in this manner. Sorry, I went ahead, but we use the symbolism darn it, I'm off here. That is what we're going to use to indicate to us that we want to find the antiderivative. You can look through these rules in Theorem 2. The one that you will use probably the most is the power rule. Basically, instead of subtracting 1 as we've done in the past, we're going to be adding 1, and we're also going to be creating a fraction where we have 1 over the exponent plus 1. We have our properties of antiderivatives. Again, these are very similar. When we have a constant times the function, we can bring it out front to use it. And if we are adding or subtracting two functions, we can separate them if that makes it better for us. I'm just going to do some examples of ones that I think might give you some trouble. The directions would read find the integral, or they may just simply say evaluate. So this first one, we want to find the antiderivative of 6 dx. This is the constant, and so it's going to become 6x plus c. Don't forget the plus c. That was my biggest downfall when I was taking calculus. I can still remember that being an issue for me to this day. Let's find the antiderivative of x to the 5th dx. Now this is the power rule. So I'm writing everything out. It's going to be 1 over the exponent plus 1 times x to the exponent plus 1 plus c, which is 1/6 times x to the 6th plus c, or even simpler, x to the 6th over 6 plus c. This next one I'm going to do because of the algebra that always seems to get into our way, it is also an example using the power rule. So we want to integrate x to the 5/6 dx. So that's going to give us 1 over 5/6 plus 1 x to the 5/6 plus 1 plus c. All right, so let's look at what's happening here. So you can do this on your calculator, you can do it in your head. Of course, you have to have a common denominator to add the two fractions, and you get 11 over 6. So at this point, we have 1 over 11 over 6 times x. We know that that added together gives us 11 over 6 plus c. Now, our problem at this point is that we have a complex fraction here. So this is just 1 divided by 11 over 6, which is 1 times 6 over 11, or 6 over 11. So our final answer is 6 over 11 x to the 11 over 6 plus c. All right, so let's look at this. This is another nice, straightforward. We have to integrate 9x to the second minus 6x plus 2 dx. And I'm just going to go through one by one. So this is going to be 9 times x to the third over 3, because we've added 1 to that exponent. Don't forget there's an unseen 1 here, so that's going to be minus 6 times x to the second over 2, and then plus 2x, not forgetting the plus c. Simplify, and we get 3x to the third minus 3x to the second plus 2x plus c. I've got one more before I kind of switch gears and go into logarithms, and I'm choosing this one because I know that the square roots have given some of you problems in the past. So I would change this so that I want to find the integration of x to the power 5 over the index 2 dx. So I'm just rewriting the square root. And so when I do that, that will become 1 over 5 over 2 plus 1 x to the 5 over 2 plus 1 plus c. I'm going to let you figure all that out on your own, because we just did that compound fraction a minute ago, but our final answer will come to 2 over 7 x to the 7 over 2 plus c. All right, let's look now at one that involves a natural log. So we can rewrite this as 7 times the integral of 1 over x dx. And 1 over x dx is our natural log. So that's going to become 7 times the natural log of the absolute value of x plus c. Make sure to use your absolute value symbols there. And then let's wrap it up nicely where we're looking to integrate e to the negative 11 over x. I mean, not 11 over x, to the negative 11x. This is the one where we have e to the ax. And so that's, I need to put dx here, please. So that's going to give us 1 over the a, which is the negative 11, to the e to the negative ax plus c. And you could simplify it to that if you wanted to, but the key point there is to make sure that you know the negative 11 is the a, and that's what we're dealing with. Now there is, okay, so we have this word problem where we're told that the rate at which the machine operator's efficiency E expresses a percentage changes with respect to time t and is given to us by this. What is the number of hours the operator has been at work? So for step A, it wants us to find E of t, given the operator's efficiency after working 2 hours is 76%. In other words, that is E of t, or E of 2, is equal to 76. Okay, so let's start first by integrating. So we'll look at the integration of 30 dt minus the integration of 8t dt. So 30 is a constant, and we'll add the t to that. And remembering that there's an unseen 1 on the t, we will be subtracting 8t squared over 2 plus c. Now, what we want to find is E of t. And E of t means we have to also know what this c value is. So here is how we're going to find that c value. We're going to use this information here. This is E of t equals our I'm just going to put percent. So we're going to actually look at this and it starts out as E of t is equal to 30t, not plus, minus 4t squared plus c. But of course our problem is we don't know what c is. But we do know that t is 2, and we know that E of t is 76. So I'm going to substitute in the values that we know. So we have 76 is 30 times 2 minus 4 times 2 squared plus c. And our goal here is to solve for c. So we'll have 76 equals 60 minus 16 plus c, or 32 is equal to c. Now that we actually know the value of c, we can say that E of t is equal to 30t minus 4t squared, and instead of plus c, we know c is 32. So now we want to use the answer in part A to find the operator's efficiency after 3 hours and after 5 hours. So let's look at 3 hours first. So all that means is we're going to substitute 3 for t. And that will give us 86. And you'll see in Pearson that our percent symbol is beside it. And then finally, let's do after 5 hours. So again, we're just substituting 5 in for t. And that will give us, again, they'll have the percent symbol beside, and it will come to 82%. I hope that was helpful. Have a good evening.